afternoon, ladies and gentlemen. My name is Dr. John Belkwitz. I'm Director of R&D at Intelligent Concrete. We specialize in saving the world with all the concrete in it. I'm with
Brent Rollins with Spraylock Concrete Protection.
God, dude.
I'm the Director of R&D with Spraylock Concrete Protection based in Chattanooga, Tennessee.
And I just smacked your arm. I'm so sorry.
Okay.
He's
Don't let it happen again.
He's a tough guy. So we're here at ASTM, and I wanted to interview Brent about who he is, what he does, and why he's here. So let's just dive into this. You already said who you are, who you work for, but why are you here?
Oh, wow. What a loaded question, but a great one. So why I'm here is because colloidal silica is the most active pozzolan known. And when I talk about pozzolans, what I'm talking about is a material that's able to react with some of the byproducts of cement and water hydration that fills void space, closes capillaries and pores to reduce the permeability of concrete, which we all know increases durability. So if we can increase durability of concrete, we can make concrete last longer. That's what it's all about, right? All right, so the real why behind why I'm here is too much of our concrete is not lasting as long as we want it to. And I got an opportunity to study that at the university that I worked at. I got an opportunity to study just why is our concrete not lasting as long as it should. And the answers that we came up with is that we're not really designing it for durability. We've only recently begun taking durability in as part of the equation. Colloidal silica is able to reduce that permeability, keeps the water and things that water carries out of the concrete, like chlorides. Chlorides cause rebar corrosion, reinforcing steel corrosion. That's one of the main failure mechanisms in concrete today, in reinforced concrete. That rebar corrosion starts to happen and it blows our concrete up. So we want to reduce that. We want to make the concrete last much, much longer than what it's lasting.
So why ASTM? Why not just hustling on the street, for lack of a better term? What does ASTM give?
Sure, ASTM is the go-to for specifications and testing for construction materials, and especially concrete related materials. You got to have sort of a framework to work in so that engineers and architects and people that specify your materials know that it's sort of been giving a good housekeeping seal of approval. So
Beautiful. That's beautiful.
so that they have confidence that the material does what it says it's going to do, and that they can design properly with the material.
That was so awesome. That's like spot on. So this, I think, is probably this is the last question, but the most difficult question. And I have a little bit of a bias on this. I got a dog in the fight. So I'm not going to react, I promise. What do you like more? Colloidal silica in concrete, mixed into the fresh state, or colloidal silica sprayed onto concrete?
That's a great question. The answer is both.
It just got bowed up. Sorry.
Well, yeah. So the products that our company produces, we have an integral colloidal silica and a spray applied. For durability purposes, if I had to pick one, I would pick the spray applied colloidal silica, and the reason is just simply that with the spray applied colloidal silica, it's going in the capillaries and bleed water channels that are already formed.
Oh yeah.
So it's closing those once they've already formed. The integral does a wonderful job of reducing the size of capillaries and pore space, but there are still some there, possibly, depending on mix design, depending on a lot of different factors. So when you combine the two, that's when you get the best of both worlds. And that's where we see some tremendous improvements in things like chloride diffusion rate, where you see 70+% reduction in chloride diffusion rate. So the answer is both, but if you had to choose one, I would go with the spray applied.
And I know y'all don't normally do this. I like the spray applied because you can use that as a retrofit. And I don't think y'all have done that much, but that's where I like to see it on structures that are already aged and you're trying to get a few more years out of them.
Sure.
They're not totally falling apart, but you still want to increase the durability.
Sure.
The retrofit, you cannot mix colloidal silica into concrete that's 10, 15 years old. It just doesn't. But spray applying it.
Sure, and we do some of that. There are some more difficulties that come when you're talking about old concrete. One being that you got to make sure that the colloidal silica can get into the concrete.
Right, totally.
So things like carbonation or things like contaminants on the surface can cause a barrier for the colloidal silica to get in. So with some mechanical preparation in some cases, shot blasting, water blasting, whatever the case may be, whatever's needed, then you can get that colloidal silica into the concrete itself. And as long as calcium hydroxide is present or other, the alkalis are present, then the colloidal silica will react and form more calcium silicate hydrate to fill those capillary and void space. As long as that's still there, and we've treated some pretty old concrete, as long as it's still there, then it should do what it's supposed to do, as long as it can get in.
Amen.
Yeah.
Amen. Absolutely love that. So thank you, sir.
Thank
You're
you.
a scholar as well as a gentleman.
Thank you, John.
Appreciate y'all standing by. Let us know if you have any questions, any concrete concerns, especially as it pertains to colloidal silica. We'll be more than happy to answer them. Go concrete! You're supposed to say
Beat asphalt. Yes!